All right, hello, my name is Marcus, and I will be talking about the point that I did for the throwing a dart challenge. My point ended up right here to the left of Mexico. I thought it was kind of cool because it's right kind of in the Gulf of California. I know it's not technically like ocean, but it's right by the Pacific Ocean, so I'm counting it. I did the research on it, and the age of this seafloor is actually fairly new. If you look right here, I kind of have it pulled up, right to the left of Mexico, at about 30 degrees north. It's the red, which is the beginning of that spreading center. So it's the spreading center that Gulf of California falls on, and my point is right at that. So the age is fairly new, and so that kind of leads us to the depth. The depth is not so deep. It's actually, sorry, it's a little wigging out, but if you look down at the key at the bottom, it's the green and yellow is about 1 to 2, the elevation in kilometers, and right here it's kind of like that green and yellow color. So it's not too deep. It's actually pretty shallow or pretty high up compared to some of the other places in the ocean. Like over here, it's like -6. It gets a little bit crazy up in that Pacific Ocean, but over by that Gulf of California, it's pretty, the elevation is pretty high up there. For the kind of what's inside of it and like the physicals of it is the top one has the most. It's that chloroform concentration. You can see it's kind of got the green or yellow in each little graph here, which that green is about 0.3 to 0.1. So it does contain those level of chloroform, and this is due to the biomass that is actually on that seafloor. So the Gulf of California, actually the seafloor is kind of covered in the diatoms, which are a form of phytoplankton, and those diatoms are what produce that chloroform because of the biomass, and that's what causes that chloroform concentration. So it's from the phytoplankton that's on the sea level or the seafloor. And next we have the thickness, which this key right here, on the right side is the colors that we're going to use, which is 0.5 to about 1.5, if that. We'll scroll over here. You can see it's that like bluish green to like the darker blue right over there. So that, yep, is like very, very, very thin to getting the thickness of about 0.5 to 1. So we know that it's at that spreading point, so that's why it's so thin, because it's just beginning, and it hasn't quite gotten all of that thickness that it can, spreading throughout the Pacific Ocean. And then next, which is kind of my favorite part, are the sediments. So I'll kind of keep looking at this one so you can see that this Antarctica, I'll switch over. This Antarctica kind of has all of these siliceous, I don't know if I'm saying that right, siliceous sediments at the bottom by Antarctica. And that's all like the glaciers that are keeping those, and like the cold that's like pushing that up. And you can see right by South America, it pushes it up all the way up into that Gulf of California. So the siliceous sediments are right in there, mainly in that Gulf of California. But you can see around there's that red clay, and that red clay is kind of very prominent also in that Gulf of California. The dark and red clay deposits are there, and then there's also the like biogenic sediments from the phytoplankton. Sorry, it kind of took me a little bit, but yep, from that phytoplankton, they also cause other sediments that are on the ocean floor. We kind of talked about that. The chloroform concentration